Rick Crosslin on the total solar eclipse 2024. Very soon, this fabulous phenomena is going to be in our backyard. So this is a great time to learn everything we can about total solar eclipses, so you'll have a, as they say, a better prepared mind for this great observation you're going to make. I spent a lot of time trying to explain how a solar eclipse occurs. And basically, it's easy at first when you think about you need a shadow. And to make a shadow, you need three things: the sun, which is a light source, an object, which is the moon, and a surface for the shadow to land on, which in our case is going to be the Earth. So those three things, but that's the easy part of a total solar eclipse. The hard part is to try to answer the question, why don't we have them every month? So I've tried different methods and different models to explain how and when we have total solar eclipses. And so I am the Earth, and here is the sun, and here is the moon going around me. It is actually off of the elliptical plane, and it goes around, and there's only a couple times that it actually lines up. But that is kind of hard to explain. By tilting the moon 5 degrees off of the ecliptic, you can see how it only lines up certain times. But even that has its limitations. The Orreries have been around for 2,000 or 3,000 years, when people have made mechanical models to show how the Earth, the moon, the planets move. This one, like all models, has its limitations. Here is 1 year, and you can see that it's rotating and revolving in the month, and I can almost see a solar eclipse shadow. And I love this one here. This one is electrical, and it's got all the mechanics. It's showing a year, it's showing day, night, it's showing the months. If you make something to the correct scale of size and distance, for example, this Earth and this moon, 1/4 the size, and this distance is correct. 9.5 times the circumference of your object gives you that correct distance. Of course, even in this model, if I did this, the sun would have to be 13.5 feet in diameter, filling up this stage. So I decided we should make our own Orrery to explain why total solar eclipses only happen about twice a year during the eclipse season. I enlisted the help of my friend Todd Hendricks and Matt Liles to make this handmade, customized, one-of-a-kind Orrery. And let me introduce the players. So here is the Earth, the big blue marble, and coming on around we have the moon, and that moon comes around, that's 1 month, or month, if you like it, and that takes 29 days, about 4 or 5 hours, some minutes, some seconds, because none of these things are exact to our time in our calendar. They rotate by the laws of physics, but not by our watch. And let's show you what 1 year looks like in our Orrery. There's a month, let's say that's January. And so I'm going to go on around. Okay, that would be happy birthday. I'm 1 year old. And if I had the moon set right, that would have been 12 months for us to go one complete revolution. Now, this is where it gets very interesting. Right now, there's something I'd like to explain to you. It's called the elliptical plane. If you can imagine a line right here halfway through the Earth, and a line where the moon is right even, and it goes right here to the sun, this is called the elliptical plane. The planets revolve around the sun on this plane. The moon is actually 5 degrees off the elliptical. And so I'm going to adjust this, and this is a better representation on this model of how this all works. So I'm keeping it tilted 5 degrees as we go around, and the first thing you notice, we've lost the umbra. It's gone. Even when I turn on the rotation, as it comes around, it's too high there, it's too low on that side, and that's how it's always going to be. Except for 2 times during the year, 2 times during the elliptical orbit, it should line up where we see an eclipse. That's our eclipse season. And let's see if we can do that with our model. So I'm going around an elliptical umbra right on the Earth. And this is one of the 2 times that we'll see it. Let's keep it going. And that here, 3 months later, it's too high in the back and too low in the front. Was as we expected, way too low here. But we have one more chance for it to be right on a total solar eclipse. So that's why we have what we call the eclipse, total eclipse season. Twice a year, where the tilt works it out that the moon passes through the elliptical and shines an umbra somewhere on the Earth. Now, where? That's a good question, because there's a lot more math involved when you add the tilt and time. But I hope this helps you understand why it's going to be such a unique experience that on April the 8th, 2024, we're going to see this umbra cut a path from the Pacific through Mexico, through Texas, through several states, and more importantly, right through Indiana, where you're going to be able to see this. All across the nation, somewhere, wherever you are, you will see a partial. But if you're along this path of totality, you'll get the full show. Don't miss it. It's not going to come back to North America for 20 years. It's not going to come back to Indiana for over 220 years. I'll see you outside looking at our total solar eclipse.